All right, guys. End of these notes and the beginning of y'all being ready to take your test pretty soon. Sue. Same question as before. Match the slope of differential equations. I have these differential equations. I have these slope fields, and I have these differential equations. I got to figure out which is which. Some of you might be like, "Can't I just solve this and see which one this looks like?" And the answer is, sure. You want to do that? That's fine. But it might be kind of a pain in the butt. So I see this one has these zero slopes right here. And this line, yeesh, that is a terrible drawing of the line. That line, that's better. This line is like, it's not y equals x like it was last time. This time it's like y equals negative x. So when x and y are opposites, this slope should be 0. And that's going to give me this one, right? When x and y are opposites, x plus y is 0. So this one matches up with A. We got a couple other options here. This one looks like when x is 2, dy dx should be 0, because 0.5 times 2 is 1, and 1 minus 1 is 0. So this one should be one where when x is 2, y is 0. No, that right here, x equals 2, y equals 0. So this is B. Don't have to worry about this one or this one anymore. This one, dy dx equals 0.5y. So when y is 0, then the slope should be 0. Okay, so that'd be like here. It's kind of hard to see if those lines are really, if there's really lines there. I would imagine the way that this is looking, that there are probably horizontal lines here, but maybe we don't know how to do that one yet, so we'll look at this one instead. Dy dx equals x over y. This is 0 when x is 0. Well, then it can't be this one, because x is 0 right along the y-axis here. And these slopes are clearly not 0. So this one's got to be D. You can see there's a bunch of little segments with 0 slope right when x equals 0. That's D, and that's C. This negative x over y is the one we always get when we think about the differential equations that make the equation. This is the equation of a circle. When you do the slopes for circles, you always, I don't know how to say this. X squared plus y squared equals r squared. You take the derivative of all this and solve for y prime, you get that. All right, and the last one is just, I think it's just one problem on that last page. Tis. This one's a little trickier because here they give you the y's and not the y primes. So before we were looking for places where like this, like, well, when x is 0, then, oh, but this one now is no longer y prime over here, it's just y. So it's defined to be a solution to that differential equation, which means whatever this thing looks like, y equals x squared, I would expect this to look the same. The slope fields give me the slopes, which means the shapes that they give me are the solutions. So like a specific solution to this one would look like that or something. It would be like, it would follow, you try and draw ones that are parallel. We did that in the AP question in the last set of notes. So this does not look like x squared, does not look like e to the x or even negative x. It doesn't look like cosine. It does look like the natural log of x. Whoa, that is god awful bad. Let's try that again. As I'm sure you recall, that's what y equals natural log of x looks like. So if you remember that, this picture is pretty much a dead giveaway. But just be careful. Here, they're talking about y's, whereas all the other ones, they were talking about dy dx's or y primes. So be cautious which one they're asking about. That's it for these. Y'all got plenty to do. If I don't see you, talk to you beforehand, happy Passover.